Okay, this video will be trying to finish up talking about kinetic energy. And so we left with an equation for kinetic energy, and that was that kinetic energy is equal to 1/2 times mass times velocity squared. So let's just do a practice calculation for kinetic energy. So let's say that we have a boat and it's moving at, let's say, 10 meters per second, and it has a mass of, let's say, 1,500 kilograms. And I want to know the kinetic energy that this boat has. Well, let's just do the calculation. So we have kinetic energy equals 1/2 times the mass, so 1,500 kilograms, times the velocity, 10 meters per second, squared. So that will give us 75,000 joules. What that means is that this boat has a kinetic energy of 75,000 joules, which means that at the very least it can do 75,000 joules of work on something. Right? And we see that as velocity increases, the kinetic energy increases, and as the mass increases, the kinetic energy increases. And that actually kind of makes sense. So if you think about if I were to get a bowling ball, right, and I were going to throw it, and I had lined up a whole bunch of pins for it to knock down, and I wanted to know, well, how many pins can it knock down? So which would be another way of saying how much work can it do before it has to come to a stop, before it's out of energy? Well, the faster I throw the bowling ball, the more pins I'll be able to knock down. And if the velocity is constant and I just increase the mass, then I can also knock down more pins. So that should be kind of intuitive. So let's think about a thought experiment. So say I have two boats that are racing. These are weird looking boats. So it'll be boat A and boat B, and they're racing, and they're racing on a frictionless surface. So I don't really know where this is taking place. Maybe this is taking place in outer space or something. I'm not really sure. And the force on these boats is from the wind, and it's the same force for both boats. But I'm going to tell you that boat A has 2 times the mass of boat B. Here's the finish line. So they start at the same place, so they go the same distance, the same force is on them, and I want to know which boat has more kinetic energy when it passes the finish line. So we could actually do this calculation if we put numbers to it, and it would probably take, a good amount of time. So let's actually just think through it is what I want you to do. So if kinetic energy is the amount of work that is needed to get a boat, or get an object, I guess, to accelerate to a certain velocity, right? So that's what kinetic energy is. And we know that both boats start at rest. Then we know that work is done on the boats, right? So they accelerate, they start moving. And if we really think about it, we can say with confidence that boat A and boat B will have the same kinetic energy when they cross the finish line. And that's because there's the same force, right? So this is the force of the wind. The same force is on both boats, and that force is applied for the same distance. So the same amount of work is done on both boats, right? Which means that the same amount of energy is transferred to both boats. And it's being transferred to their motion, so the same amount of kinetic energy is transferred to both boats. So because they go the same distance, the same amount of energy is transferred to them. So when they cross the finish line, they'll have the same kinetic energy as each other, which doesn't mean that they'll both be going the same speed, because they're not. But we know that the kinetic energy is the same because the amount of energy transferred to them is the same. And if that makes sense, then you probably pretty much get kinetic energy.